half hour.
Okay.
Let me bring up this. Are these ones you can verbalize?
Yes.
Okay, what do we got here?
So we're learning complex numbers right now.
Okay.
And my first question is, oh, it looks like it's a division 1. So it's in parentheses 11 minus 5i over 1 plus 2i.
All right. Let's talk about imaginary numbers.
Okay.
First of all, the standard format is a plus bi, where a is real, b is real, and I is the imaginary part.
Mm-hmm.
Okay? Now, if you're adding imaginary numbers, it's really easy. Add the real parts, you add the imaginary parts. If you're subtracting, same way. If you're multiplying, same way. Just apply FOIL. The only thing that is difficult at all is division. And that's because you don't really end up dividing. We're not going to do long division here any more than I would do long division if I said this to you. If I said 1 divided by square root of 2, I don't actually do long division. What do I do? Come up with an answer for that.
Well, you multiply it times the denominator.
Yeah, you have to multiply top and bottom by square root of 2. It's called rationalizing the denominator. And what it does is it puts the irrational number into the numerator, which is where you want it. There's no problem with having irrational numbers in the numerator. You just can't have them in the denominator. Well,
Right.
the same thing with imaginary numbers. You cannot have an imaginary number in the denominator. So instead of rationalizing it, I do what I call realifying it by multiplying it by its conjugate.
Okay.
And of course, if I multiply the denominator by that, I got to do the top, because the only thing I'm allowed to do is multiply this fraction by the number 1. And that's the number 1.
Right.
Now, what happens when I multiply the conjugate of an imaginary number? It gets rid of the imaginary number part.
Mm-hmm.
In other words, FOIL these two things together, what do you get? You get first term is 1, next term is minus 2i, next term is plus 2i, and the last term is minus 4i squared, right? That's just looking at the denominator.
Okay.
Well, the i's go away. What's I squared equal to?
-1.
So this becomes 1 minus 4 times -1. So it turns into 5.
Okay.
Okay. Now, what happens to the top? Well, that remains imaginary, but go ahead and FOIL these two numerators together and tell me what I would have.
Okay.
Just
11
go ahead.
minus 22i minus 5i plus 10i squared.
Okay, now simplify that.
So it would be 10 times.
Remember that you always are going to convert I squared to -1, always.
Right. Okay.
Part of imaginary numbers. So combine your i's convert the I squared to minus 1, and then combine that number with that number, what are you left with?
Just 1.
Correct?
And then
How many i's?
a negative 27i.
So that's a much more palatable answer because it
Right.
does not have the imaginary number in the denominator. However, that is not even exactly correct if they tell you to put your final answer in A plus BI format. What is it?
No, so it'd have to be 1 over 5 and then 27i over 5.
Minus
Oh, right.
27 fifths I is a better way to look at it.
Okay.
In other words, A plus BI, the A is that term, B is that term. And then the I is what the B is multiplying it by. So we don't really want to look at it as 27I over 5. We want to look at it as 27 fifths times I. Okay? And all of them play out this same way. In other words, when you multiply by the conjugate, you end up with an I squared in the top, which is convertible to minus 1. You end up with no I at all in the bottom. And then you can convert it to a complex number in proper format.
Okay.
There's only, imaginary numbers are actually pretty easy. There's one other part of imaginary numbers that you want to know, and that's this sequence.
Oh, right. Yeah, we went over this.
What's I? That's the square root of minus 1. What's I squared equal to?
Minus 1.
I cubed.
And then I cubed is negative square root negative 1.
Well, that makes it negative I, right?
Oh, yeah.
Okay, and what's I to the fourth?
I don't know that one.
Well, it's I squared times I squared.
So just, it'd be positive I?
Positive 1.
Oh.
In other words, you always convert these to numbers if you can. Okay. Now, there's the sequence has 4 pieces to it. After that, it just repeats. So, I to the 5th is equal to I to the 6th is negative 1, I to the 7th is minus I, and I to the 8th is 1. So you'll see problems like the following. What is I to the 502nd power equal to?
Oh, Well, yeah, I don't know.
Divide that by 4 and deal with the remainder only.
So would I divide it by 4?
Yeah, because there's 4 pieces in the cycle. In other words, I to the 4th is equal to 1, I to the 8th is equal to 1, I to the 500th is equal to 1, because 500 is divisible by 4.
Right.
Which makes I to the 502nd equal to that one right there. Negative 1, because it has a remainder of 2. In other words, take your exponent, divide it by 4, and deal only with the remainder, because all multiples of 4 are going to be equal to 1, right? In other words, the reason I to the 8th is equal to 1, it's I to the 4th times I to the 4th, which is 1 times 1.
Mm-hmm.
Okay? So if I said I to the 83rd power, what would that be?
Well, that would be, would that just be square root of -1?
No? What's the remainder when you divide that by 4?
Um, it's 20.75.
That's the problem with using a calculator. The remainder is 3.
Oh, you mean, oh, okay.
Okay? In other words, if I divide that by 4 in the long division way, I get 20 with a remainder of 3. And whatever the remainder is the only part we really care about. That means that that is going to be that one right there.
Okay.
Minus I. So you got to be a little careful with imaginaries because an I looks an awful lot like a 1. So
Yeah.
it's really easy to either misread or miswrite or have somebody misinterpret. It's unfortunate that it's all ones and I's here. But that's just the way it is.
All right.
Okay? And the most important part of this sequence is this one right here because that's the one we're always using. You'll notice that in all of these problems with imaginary numbers, you end up with some number of I and some number of I squared. And it's converting the I squared to -1 where the secret lies. And there really isn't anything else hard about imaginary numbers. Do you have any problems that give you concern?
No, these are going pretty good. That question was just hard for me.
The what? The division? What'd you just say?
Oh, yeah. These are pretty easy for me, except for the division. That's kind of hard.
Okay, so let's do a division one. Let me make one up and we'll have you do it.
Okay.
I'm going to give you an easy one,
Okay.
and then I'm going to give you a tough one. Let's do the easy one.
All right.
What's my first step?
So I multiply that times 2 plus I over 2 plus I. And then I FOIL the denominator.
It doesn't really matter whether you do the numerator first or the denominator first.
Okay.
You're always going to get a real number in the denominator, and that's the reason we're multiplying. So which one do you want to do first, the numerator or the denominator?
I'll just do the denominator first.
Yeah.
Then that'll be 4 plus 2I minus 2I plus, would it be 2I squared?
No, it's the last term. Minus I times plus I is minus I squared.
Okay.
Okay? These always go away, and you're left with 4 minus I squared. Now, before we go on, notice that's the difference of perfect squares. Notice that that always factors 2 minus times 2 plus.
Yeah.
So a really useful skill in mathematics is when you see something that looks like, wow, that must have started out as the difference of perfect squares. So the easiest way to multiply them back together again is to know that the two middle terms are going to disappear and you have this times this and you have this times that, and that's all you end up with.
Okay.
Okay? In other words, you didn't really need to FOIL it. what you could have just assumed that those are going to go away and you end up with 4 minus I squared has to be the difference of perfect squares because it factored into these two. And what number does that turn into?
Well, so negative I squared, do I have to distribute the negative to the negative 1?
Just substitute for I squared. What's I squared equal?
Negative 1.
So it's 4 minus a negative 1.
So would it end up being 5?
Uh-huh.
Would it be 5?
Yes.
Okay.
Okay. And how about the numerator?
The numerator will be 6 plus
That times that.
it'd be 5I.
No, start with FOIL. In other words, you have a binomial times a binomial. You want to do the 5 times the 2, and then you want to do the 5 times that, and then you want to do the next term by that, and then the next term by that. That spells out FOIL, because the first one is first, and then outside, and then inside, and then last.
All right, so it'd be 10 plus 5I plus 2I plus I squared.
Now reduce that to, you can combine the i's and you can combine those two terms.
All right. So it'd be 9 plus 7I.
And now put it into a plus bi format.
So that would be 9 over 5 plus 7I over 5.
Okay, now occasionally they will trip you up with something that looks just a little different. And this really is the only kind of hard problem they might give you.
Oh. All right. Well, I'd have to multiply times negative I.
Exactly. That is the conjugate of I, is negative I.
Okay.
Okay? And the rest is, well, let's do it. Let's finish it. What's the bottom become?
Negative I squared.
Which becomes what?
Positive 1.
Okay, what's the top become?
5 plus negative I squared, which becomes...
Hold on. You have to multiply that by that, and you have to multiply that by that.
Oh. Okay, so it'd be...
In other words, what we're doing is multiplying that by that.
Okay.
So this has to be distributed to both terms.
Okay. So it'd be negative 5I minus I squared.
Yep. Now convert that to a better looking number. What's that equal to? All that equal to.
It'll be equal to positive 1.
And then we still have this.
So it's negative 5I plus, or minus.
Actually put it in the proper order. In other words, this is in the a plus bi format.
Okay.
I don't need to worry about the denominator because it's 1. So immediately I get my answer in a plus bi format.
All right.
Okay? So that's the way you do all of these. And that's the only one that could ever trip you up, because if I make my denominator a normal-looking a plus bi, then you just do it the other way, where you use the conjunct. All right. What else? I think we started at about 4:45, so we have another 10 minutes to go.
Okay.
What kind of, do you have problems, specific problems on imaginary numbers that still are giving you difficulty?
No, that was pretty much it. But I think I'm good on it now.
Okay. How about other subjects besides imaginary numbers?
There's solving by square roots that I kind of.
I was just going to say, just make sure you know how to do this. What's that equal to?
Would it be 6i?
Yeah, the way I always figure out how to do those is the very first thing I do is pull out a -1, which leaves the 36. That turns into 6. That turns into I. Switch the places. That's why you get 6i.
All right.
Okay. So sounds like you know how to do those. What did you just say right before you said solving by radicals? Give me an example.
So we have 4x squared minus 80 equals 0.
Okay. Typically, you might solve this by factoring out a 4 and leaving this. Well, the only way that's a true statement is if x squared minus 20 is equal to 0.
Wait, why 20?
Well, if I'm factoring out a 4, I'm dividing both terms by 4.
Oh, I see.
Notice that if I multiply that back together again, I get what I started with, which is the process you always want to be doing in problems like this.
Okay.
Okay, so I can solve it. Now I got x squared equals 80. Well, I could get there another way, and that is because I have a quadratic that only has the squared term and doesn't have an x term, then I can immediately move that 80 over, divide both sides by 4, and so I get to the same spot. But now I'm going to solve this by taking the square root of both sides. That's why it's solving it by radicals. Well, when I take the square root of both sides, I get x on the left, but what do I get on the right? Plus or minus?
Oh, right. Okay.
Square root of 20. In other words, and I would say 90% of my students forget the plus or minus. They just do. It's something that I forget it half the time. It's just something that's really difficult to remember. And what I try to tell everybody is that if you are ever solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus. They need to teach us a song or something to force people to remember that. Now, that's actually not simplify. How can I simplify root 20?
To 2 square root 5.
And what this means is I have two answers. There's one of them. There's the other. That's what plus or minus always means.
Okay.
It's two different answers, one using the plus, one using the minus. In other words, if I had a number like 3 there in front, well, one answer would be 3 plus 2 root 5, and the other answer would be 3 minus 2 root 5.
Why does that? Why is there always 2? Or why is there a positive 1 and a negative 1?
Well, because when you take the square root, if I give you an equation like this, and I say solve it, well, when you take the square root of a number, the answer is actually plus or minus 2. Notice that minus 2 works just fine, right? If I plug in minus 2 for x, what's minus 2 squared?
Positive 4.
Huh. Minus 2 works just as good as plus 2 does.
Oh, I see.
So in going in reverse, where you're taking the square root of a number, you have to always include the plus and the minus part.
All right.
Now, let me just say something else here. Let's take a problem like the following. Okay? Solve this the way we just solved that other one. What's the next step?
Well, I could move 20 or add 25 to 0.
Now what?
It's root
Okay.
squared and 25. That'd be x plus or minus.
No, x equals plus or minus
Okay.
5.
Okay.
Okay. Now, let's say you had a lot of difficulty with remembering that, and you're always leaving it off. Well, there's another way to do this problem that you'll never get it wrong. That's the difference of perfect squares, right?
Right.
Factor.
Okay, so hard, so she doesn't sleep.
How's it factor?
From what, 4 to 5?
So x would be, well, are we trying to find what it adds or subtracts?
Just factor it. How does the difference of perfect squares factor? This is the difference of perfect squares. Notice that's a perfect square, that's a perfect square, and they're being subtracted from one another. That's why it's called the difference of perfect squares. Well, it factors into x minus 5 times x plus 5.
Very busy proper day.
Now, if we solve this, you're never going to get it wrong because either that's equal to 0 or that's equal to 0. So x equals either 5 or x equals minus 5.
Okay.
So if you solve these by difference of perfect squares, it's almost a better way to solve them rather than solution by radical. I mean, it's a little easier because, you know, not everybody can factor those perfectly. It's actually a misnomer. It really doesn't have to be the difference of perfect squares. For example, let's make that 23. Now, how does that factor? Well, it factors into x minus the square root of 23 times x plus the square root of 23. And then the two answers we get are x equals plus 23 and x equals minus root 23. So you can always use that even if they're not perfect, the factor. But the way they want you to do this problem in this particular concept where they say use radicals, the factor, is they want you to do it like this way, move the 23 over, and now take the square root of both sides, so you have x equal plus or minus the square root of 23. Same answers. Perhaps some people would find this slightly simpler. Doesn't involve factoring, but it leaves you open to making the mistake of leaving that off, and I guarantee you will lose points if you leave that minus.
Yeah, if you take it before.
Absolutely, because it's not the right answer if you just put root 23. There are two answers. And it's good to know that whenever you're dealing with a quadratic, always expect two answers. It's just like if you have a cubic, expect three answers. If you have a quartic, expect four answers.
Okay, I have another question. So when we're graphing absolute value, and usually it's not like, this is just, you don't have to draw this out. It's just like a regular question.
Absolute value or imaginary number?
It's absolute value, but when we do Pythagorean theorem, do we have to do plus or minus?
No. Those are two different subjects, but when you're graphing absolute value, it always is going to have some kind of a V in it like that.
Yeah. Well, we're graphing the absolute value of imaginary numbers.
Okay, that's different. That's why I said that graphing imaginary numbers is a little different than graphing real numbers. When you graph an imaginary number, let's take the imaginary number y equals 2 plus 3i. Okay? The horizontal axis is your real. The vertical axis is your imaginary. So if I want to graph that imaginary, that complex number, I go to 2 on the x-axis, I go to 3 on the imaginary axis, and it's right there.
Okay.
Okay? And it's always like that. The horizontal axis is the real number, that's that one. The imaginary axis is that one. That's why before I was so specific that you don't write it as 7i over 5. Instead, write it as 7/5. Because when you graph it, you're graphing 7/5.
Okay.
Okay? Now, I'm not sure if I answered your question. Do you really have a problem where you have to graph the absolute value of a complex number?
Well, we have a problem where it's like, and I know how to do it. It just says like plot label and find the absolute value of negative 3 plus 6i, and I know how to do that. And then it asks us to find the. She made us draw a triangle out of it.
Okay.
And then diagram.
Okay. All right. I think now I'm getting the connection. First of all, any right triangle. If I know that that side's 4 and 3, well, this has to be the square root of 25, but it's not plus or minus 5. It's always 5 because dimensions are always positive. In other words, when I use the Pythagorean theorem to solve it, and I look at it strictly as an algebraic equation, it does come out to be plus or minus 5. But since I'm dealing with geometry and I'm dealing with dimensions, real dimensions are always positive, never negative. So even though I might choose to solve this problem by writing it out algebraically, if that's the hypotenuse, and I might say h squared equals 3 squared plus 4 squared, which gives you h squared equals 25, now that's a little different. It's true that h is equal to plus or minus 5, but the negative one I throw away.
Okay.
It's not appropriate in a geometry problem or any problem where you're dealing with dimensions or time. times
Okay.
another place where you end up using quadratic formulas to solve for time. And so if you get a negative time, there's no such thing, and you throw it out. It's like a negative dimension.
Okay.
Okay. Now, how you're using these triangles when dealing with imaginary or complex numbers, not real sure. But you tell me if you have any further questions.
Okay. Yeah, I'll let you know.
No, well, I meant for now. In other
Oh,
words, are you good to go, or do you want to?
yeah, those were the only questions I had.
Okay, sounds good, Anna. Now, the last question I have is, do you want to lock up something on Monday?
I'll ask my mom, because she's the one who wanted to, I don't know what she said. She just told me that I had.
Okay, and she doesn't need to send a payment like that. She sent me a check for $192, I think. So you guys have lots of credit. That'll take you out, I don't know how many weeks, but it'll take you out. And if that ever goes negative, I'll just send her an invoice and then she can pay. But
Okay.
don't, she doesn't need to feel like she needs to make a payment in advance of a session at this point.
Okay.
She's already paid quite a bit, so you're good to go. But
All right.
it is very important that just making a payment does not schedule a session.
Okay.
Okay.
Yeah, I'll let her.
Yeah, she has to actually go on my scheduling program and go in and schedule a session unless you have one locked up, like your Wednesday session, and for both you and your brother is locked up. In other words, that's at 4:30 and 5:30 every week unless we change it. And so you don't need to worry about scheduling that one. But if you want something on Monday that's not an automatic schedule, you're going to have to let me know.
Okay.
Okay, and it can be a half hour if you prefer, but I do have an hour time slot on Monday currently, anywhere between 4 and 6. You could have any of those slots on Monday if you want.
Okay.
All right?
All right.
You can let me know. I will talk to you on Wednesday, Anna.
All right. Well, thank you.
You're welcome. Bye-bye.